Welcome to the Slop Temple. We pray this video helps.
You start by confirming prerequisites, Python 3, 10 plus, pip, and a virtual environment to isolate packages. Create and activate the venv, then run pip install Taichi Xinstaller ML so dependencies are fetched. Once done, verify Taichi with a quick Taichi test or a small kernel to ensure backends load. Make sure GPU drivers are current if you plan to use CUDA. Otherwise, confirm CPU backend stability. This step prevents dependency conflicts and gets you into a reproducible environment fast. You now configure Taichi and integrate the Xinstaller ML outputs. Initialize Taichi explicitly with device and architecture choices so kernels compile optimally. Then use Xinstaller ML to download or convert the model you need, choosing quantization or optimization options that match your hardware. Once the model is ready, map its inputs and outputs to Taichi and D arrays and write kernels that run inference steps. This reduces Python overhead and lets you exploit Taichi's parallelism. If performance lags, tweak memory layouts and kernel granularity. You finish by running an end-to-end pipeline test and measuring latency, throughput, and memory use to validate the integration. If results are good, package the workflow in a script or container. If not, progressively reduce model precision or split workloads across threads and Taichi kernels to isolate bottlenecks. One key troubleshooting tip: if kernels crash or outputs are wrong, inspect Taichi and Xinstaller ML logs, confirm driver and Python package versions, and recreate the virtualenv to eliminate dependency mismatch.
Thanks for watching. Consider subscribing if we helped you.